Welcome to this section on relation and function. In this part, we will solve 9 awesome questions that help you to grasp all the concepts we discussed in part 1 of this installment. Let's dive into the questions. Find the domain and range of each of the following relations and determine if that relation represents a function. The instruction is to find out the domain and range of each of these relations and to identify whether that relation represents a function or not. Question number 1. A relation R is an order pair x, y such that y is 3 more than twice of x, where x is the first 5 odd positive integers. In this question, we are given with 3 important concepts that help us to solve the problem. The first concept, the relation is given as a set of order pair x, y. The second concept, y is 3 more than twice of x, meaning to find y, that's the second element of the order pair, we have to multiply x, that is the first element of the order pair, by 2, and then we have to add 3 to the product. The third concept, x is the first 5 odd positive integers. Odd positive integers are numbers. When we divide each of them by 2, leaves us with a remainder. Usually that remainder is 1. So let's solve this problem starting from finding out the 5 odd positive integers. That's x equal to, the smallest odd positive integer is 1. To find the next 4 odd positive integers, we have to count it by 2, starting from the smallest odd positive integer. Counting by 2 means simply adding 2 to a given integer to find the next odd positive integer. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, and 7 plus 2 is 9. So the values of x, or the first 5 odd positive integers, are this. We are also given that y is 3 more than twice of x. That relationship can mathematically be expressed as y equal to 2x plus 3. X values are known. By substituting each value in place of x, we can solve for y. When x equal to 1, y equal to 2 times 1 plus 3. 2 times 1 is 2. 2 plus 3 gives us 5. When x equal to 3, y equal to 2 times 3 plus 3. 2 times 3 is 6. 6 plus 3 gives us 9. When x equal to 5, y equal to 2 times 5 plus 3. 2 times 5 is 10. 10 plus 3 gives us 13. When x equal to 7, y equal to 2 times 7 plus 3. 2 times 7 is 14. 14 plus 3 gives us 17. When x equal to 9, y equal to 2 times 9 plus 3. 2 times 9 is 18. 18 plus 3 gives us 21. Now, we know the values of x and the corresponding values of y. So we can write the order pairs as r equal to, when x is 1, y is 5. So 1, 5 is the first order pair. When x is 3, y is 9. Thus 3, 9 is the second order pair. And the remaining 3 order pairs are 5, 13, 7, 17, and 9, 21. Domain of relation equal to, domain represents the value of x, that's 1, 3, 5, 7, and 9. Range of relation equal to, range represents the value of y, that's 5, 9, 13, 17, and 21. A relation is function only when each input or value of x pairs with a single output or values of y. If one input pairs with 2 or more different outputs, that relation is not a function. In our relation, which is expressed as a set of order pairs, we can't find an input paired with more than one output. Thus, this relation is function because each input has only one output. In moving to question number 2, r equal to, an order pair xy such that x is a daughter of mother y. In a given order pair, x represents a daughter and y represents mother. Thus, domain of relation equal to daughters or daughter of mother y and range of relation equal to mother y. If mother y has three daughters named Soliana, Eldana and Aster, then the relation can be expressed as a set of order pair by mentioning daughters in place of x and mother y in place of y. Soliana, mother y, Eldana, mother y, and Aster, mother y. As we can see here, the input or the daughter can't relate with two different mothers. Thus, this relation is function because a girl can't be a daughter of two or more mothers. Here, when we say mother, we mean biological mother. Bear in mind, when one input relates with two or more different outputs, that relation is not a function. But if two or more inputs relate with a single output, that relation represents a function. The case happening here is that in casting forward to question number 3, R equal to order pair xy, where x is a factor of y and y represents the first three positive even integers. Again here, we are given with three informations that help us to solve the problem. The relation is presented in the form of order pair x, y. The first element of the order pair, that's x, is a factor of the second element, that's y. And y represents the first three positive even integers. It's clear that the values of y or the first three even positive integers are 2, 4, and 6. It's stated that x is a factor of y. Factor is a number that divides a given number evenly or exactly, leaving no remainder, or the remainder is 0. If we divide any number by 1, it gives us the number itself. So 1 is a factor of any number. If we divide a given number by itself, it gives us 1. Thus, any number is a factor of itself. I think you understand what factor means. If so, let's identify the factor of each of these three numbers. Let's start with the factors of 2. 1 is a factor of 2 because, as we discussed above, 1 is a factor of any number. 2 is also a factor of 2 because any number is a factor of itself. When we move to 4, 1 is a factor of 4. 4 divided by 2 gives us 2 with no remainder. Thus 2 is a factor of 4. And number 4 is a factor of itself. When we come to 6, 1 is a factor of 6. 2 is a factor of 6 because 6 divided by 2 gives us 3. 3 is also a factor of 6 because 6 divided by 3 gives us 2. 6 is a factor of itself. Since we figure out all the values of x and y, we can list out the domain and range of the given relation. Domain of relation equal to 1 is found in all these three sets, so 1 is an element of the domain. Also 2 is there in all three sets, thus 2 is also an element of the domain. Other elements are 3 is here, 4 and 6. Range of relation equal to, range means simply the values of y, that's 2, 4 and 6. It's given that the relation is an order pair x, y, meaning each y value pairs with its factor to form a set of order pairs. So let's form that order pairs. The relation are equal to each of these two factors of 2 paired with number 2 to form order pairs 1, 2 and 2, 2. These three factors of 4 paired with number 4 to form these three order pairs. And finally, the factors of 6 and number 6 paired to form these 4 order pairs. This relation is not function because one input has more than one output. As an example, if we consider number 2, it pairs with number 2, number 4 and number 6, meaning the input 2 has 3 different outputs. That's why this relation is not a function. Question number 4. The relation R equal to The set contains these 7 order pairs. It's already given by enumerating list of all order pairs. Hence, we can easily figure out the domain and the range. Domain of relation equal to x values in the given set are -1, -6, 7, -3, 9, 1, and 6. Let's arrange them in ascending order. The smallest one is -6, then -3, -1, 1, 6, 7, and 9. Range of relation equal to range refers y values in the given set. The smallest y value is -5. The next one is -1, then 2, then 10, 11, 12, and the highest one is 20. As we can see here, no x value is paired with more than one y value. Thus, this relation is function because every input has only one output. Question number 5. Are equal to these order pairs. It's a set containing infinite number of order pairs. Because these 3 dots express its continuation following the same pattern, in the order pairs listed out, each y value is greater than the corresponding x value by 1. Thus, that same analogy applies to the entire set. Domain of relation equal to x values in increasing order are 1, 3, 5, 7. This is not an exhaustive list, so we have to show its continuation by making 3 dots. This set represents odd positive integer. Thus, the domain can be expressed as a set of odd positive integers. Range of relation equal to y values in ascending order 2, 4, 6, 8, etc. This set represents even positive integers. So you can express the range as a set of even positive integers. In a given set of order pairs, one input pairs with only one output. Therefore, this relation represents a function because every odd positive integer pairs with every even positive integer next to it. Question number 6. Let A equal to a set containing these 3 elements and B equal to a set containing these 3 elements. R is a relation from A to B and order pair x, y element of R if and only if y is a multiple of x. Order pair x, y is an element of the relation if it fulfills the following 2 requirements. The first requirement, if it is formed as a relation from A to B, meaning if the order pair is formed by taking one element from A and relate it with every element in B. The second requirement, the output y has to be a multiple of the input x. First, let's form a relation from A to B. A cross B equal to form these order pairs, we have to take one element from set A and form order pairs by relating it with set B. 2 relates to 6, 2 relates to 8, and 2 relates to 9. When moved to 3, 3 relates to 6, 3 relates to 8, and 3 relates to 9. The last element of set A is 4. 4 relates to 6, 4 relates to 8, and 4 relates to 9. This is the whole list of a relation from A to B. As we discussed above, an order pair is part of a relation only when y is a multiple of x. So let's choose an order pair of which y is a multiple of x. The first order pair, 2, 6, fulfills the requirement because 6 is a multiple of 2. The second order pair also fulfills the requirement because 8 is a multiple of 2. When we move to the third order pair, 9 is not a multiple of 2. So this order pair doesn't fulfill the requirement. 6 and 9 are multiples of 3. Thus 3, 6 and 3, 9 are part of these relationships. From the remaining 3 order pairs, only 4, 8 can be included in this list because 8 is a multiple of 4, but 6 and 9 are not. Thus, the order pairs that fulfill both requirements are only these 5. Domain of relation equal to Domains are x values, that's 2, 3, and 4. Range of relation equal to. Ranges are y values or set B, that's 6, 8, and 9. This relation is not function because the inputs 2 and 3 each pair with two different outputs. When we move to question number 7, the difference with question number 6 is we form a relation from B to A, and the order pair x comma y is an element of the relation only when x is opposite of y. So let's start by forming a relation from B to A. B cross A equal to, in this case, we have to take one element from set B and then relate or pair it with each element in set A. -1 paired with each of these three elements of set A. The same is true for the rest three elements of set B. From the exhaustive list of a relation from B to A, we have to pick those order pairs having opposite input and output values. We have only two order pairs that fulfill this requirement, 1, -1 and 2, -2. Domain of relation equal to a set containing 1 and 2. Range of relation equal to a set containing -1 and -2. This relation is function because each input has only one output. Question number 8. Let A equal to a set containing these three elements and B equal to a set containing these three elements. Circle those which are not a subset of a relation from A to B. To solve this problem, we have to form a relation from A to B, and then we have to check whether the order pairs in each choice found in the relation we form or not. If all the order pairs of a given choice are found in the relation, that choice is a subset of the relation. Otherwise, it's not. So let's start by forming a relation from A to B. A cross B equal to, relating 1 with each element of set B gives us 1, 6, 1, 7, and 1, 10. By pairing 2 with each element of set B, we will find 2, 6, 2, 7, and 2, 10. Relating 5 with each element of set B gives us 5, 6, 5, 7, and 5, 10. Choice A has three order pairs. 1, 10 is here, 2, 7 is here, and 5, 6 is also here. All order pairs of choice A are elements of the relation. So choice A is a subset of a relation from A to B. In casting forward to choice B, 1, 6 is here, 2, 7 is also here, and 5, 10 is here. So choice B is also a subset of a relation from A to B. We don't have an order pair 6, 1 in the relation. So choice C is not a subset of the relation. Thus we have to circle it. Also, we can't find order pair 7, 5 and 10, 2 in the relation. So choice D is not a subset of the relation. All order pairs of choice E are elements of the relation. Thus, choice E is a subset of the relation. All three order pairs of choice F are not found in the relation. Hence, choice F is not a subset of the relation. Question number 9 is presented in the form of diagram. From this relation, it's simple to determine domain and range. Domain of relation equal to. Domains are elements as the left-hand side or elements as the side where the arrows start. These values are 2, 8, and 10. Range of relation equal to. Ranges are values towards which arrows are pointed or towards which the arrows are drawn. These values are -4, 0, and 4. This relation is not function because 2 maps to 3 different outputs. This brings the end of part 2. Thank you for your attention. Take care and stay safe.